I'm going to show you how you can set up an event-driven architecture for your app or company, and to do so via code as infrastructure using the AWS CDK. We will create a event bridge stack that in our AWS account will create a event bridge resource with a bus that we call main bus. We will attach this rule to it, and this rule will filter all the events we send to it to this SQS queue. You see that there are currently no messages in this queue. I will also show you how to send messages to the bus and how these messages then end up in the queue. I've prepared these two endpoints here. So now we send an event. It is now visible here in the messages available. And here we can even see it. We can see the hello world that I sent. And so how do we actually do this the proper and nice way? First, some requirements. You will need to install CDK and bootstrap your project, or just create a repository. This is quite simple. You also need to create an AWS account or have one provided to you. And you should create a user, because with this user, you can see I created this one here, Michael, my name. You need to create security credentials and save them to a specific file. .aws is the folder, and then credentials is the file in that. And you need these steps to authenticate. But let's get started. First, what is CDK and why do we use it? We can do all of these things simply manually in the AWS console. This thing here is called AWS console, and we can create an event bus like so and call it something, and this will work. However, this is going to be really chaotic and it's a bit unprofessional in that sense. So when you work with a big team or in a company, it's best to do it as code as infrastructure, which means that you write the code for the infrastructure in the AWS that you want to use and how it's connected, and then you just simply deploy this and it will work. For this, we could use Terraform, but there are some drawbacks to it, and we will focus instead on AWS CDK because it can harness a proper programming language and it can be dynamic and all these nice things. You can read up on the documentation of CDK, but basically there are stacks, and we're going to create a stack, the event bridge stack, and there are resources which we will use. And there's a certain pattern and style to the SDK of CDK. Let's first delete the existing stack so that we can start with a clean slate. Okay, now it's finished, and we still have this queue here because I didn't update. I updated and you can see the queue is gone, everything is gone, the whole stack is deleted, so we're working with a blank slate. Let's fill up this blank slate with our code as infrastructure. And this is the pattern of using CDK. You name your stack that you create something, in our case Event Bridge, as we're using Event Bridge. You extend the CDK stack, and you always have to provide a scope, an ID that is used for the CloudFormation, props, and you call it a super. And these come from here. Here I decided to manually put the env in, and this is our props, this is our scope, and this is our ID. What does CDK actually do? You can use many different programming languages with it, like Golang or TypeScript. And once you compile the language, it will compile it into CloudFormation template. And you can deploy it, upload it to AWS, and then the CloudFormation, it is the service of AWS that actually deploys this, that actually uses this and translates it into all the resources. So we need three things. We need the bus, the rule, and the queue. Let's create the bus first. And here you see this pattern extended to a specific resource, in this case the bus. We have the scope here, which is this, because we're using this class. We have the internal ID for CloudFormation to identify the resource, and we have our human label main bus, which we'll be using in a bit. And it follows a similar structure like above here. Let's create now the rule. The rule will filter the bus. So when you send something into the bus, here we have the default bus, it's always there. And we can manually send an event like so. We have to specify the bus. The source could be something like user sign up service, excuse my spelling, email changed. So this would be the event's name, this would be the source, you can give it anything, and then here of course the detail, the event detail, the payload. And we can send this event, not gonna do it. And that source and detail, you have to, this is what you filter for with a rule. You can create up to 300 rules, you can increase this limit to 900 or something per bus. And these rules filter out the events to a target. So they are basically the routing from the events to the receiver. The rule takes quite a lot of configuration as it's the pivotal connector for our purpose here. First, we should provide it with the bus that we attach the rule to. Now we added the event pattern, but it's wrong. It has to actually be in an array. So let's put it into an array. And now this is almost complete. It's just missing the target. And now we need the SQS queue. So the SQS queue actually goes in here. So let's create it before. So this is actually complete, all we need for the infrastructure at least. So let's deploy this already. You will have to bootstrap your stack like so. But I already did this. So I'm just gonna deploy it. The profile flag that you see down there is because I'm using multiple accounts and this is the personal account. So this is how I'm setting. CDK is going to make a div and going to ask us if we're happy with it. In this case, it's just the roles. You see the actual div in the console as it is actually deploying. And I can show you the actual CloudFormation. So here you see the actual stack and you see how this is being built right now. Now the deploy has succeeded and we can check the CloudFormation, but also if the resources are where we want them to be. Here you see the main bus. And you see our test rule. So this is specifically, it's matching our rule name here. And also this pattern here is matched like so. And here you can also see the pattern, how it's filtering what is being sent into the event bus. We can also check, yeah, the SQS is correctly the target here. And there are 0 messages here. I removed the code. So let's add the code to send an event because this is what is next. So we now want to send an event to the bus. And we can do so with the AWS SDK for TypeScript. And you need 3 packages for this. The first is the credentials provider to authenticate. You need to provide the keys that you provide in CDK also into your .env for your backend. You also need the client event bridge and SQS packages. Normally you would maybe set this up in the proper server, but to leave this lightweight for the purposes of this demonstrations, I'm using these Next.js API endpoint handlers, and we can just easily add our code here and test it that way. So first we need to create a client for the event bridge that we can send commands to. And we do so like this with event bridge client, and this takes a credential. This takes an options object which has a credentials attribute, and we can pass the from-env into it. And the from-env is from the credentials provider, and it will read the .env that you have and fill it up with your credentials, and then you can authenticate that way. This will fail, by the way, because we also need to specify the region. So let's do that. You can find your region in your AWS console. For us, it's Frankfurt EU Central 1, but it will maybe be different for you. Next, we need the command and the input for the command. It uses this weird pattern. You can look it up in the documentation. And here we get to the actual event that we're sending, which again, I showed you already in the UI, has the source and detail type. Remember, here's the rule where we define the source. And here's the detail type where we define it, the rule. Also, we need to specify the event bus name. We'll grab the main bus name that we declared here. And finally, the payload. We will JSON stringify it as it's a proper object, basically. Now we're all set with the input. Let's create a command and other stuff around it. So now we have the command here. We're sending it with the put events command. And with this command, we can send it to the client, to the event bridge, and this response we can log out to see what happens. So let's test this out right away. Let's ping this. Need to also start the server. We do so with next by running npm run dev, and then it will be available localhost 3000, whatever you specify, and then API, and then your file name. So we're sending it, and it is working indeed. So let's check if we have indeed a message in the queue. And you can see there is a message here. You can also see it here. We could look at it in AWS, but let's actually do so programmatically with another simple endpoint. It will be super simple. This time we need the AWS SDK client SQS, and the beginning is identical. Create a client. And now we need to send a command to the SQS, which is to receive the messages. And here we actually need the URL of the SQS queue. You can get it from the AWS console. So here we have the queue. If we now check, here's the URL, you can copy it. And we can provide it like so. And that's already it. Now we already will have the data. And that should be all. Let's already test it. You see it is working indeed. We even have the test here that we just added. Let's delete everything in this queue. Let's try again. It's empty. Let's send one message, let's send two messages. And now that we send two events, you can see that they are indeed in here, two messages available. So we send two messages, we have two messages here, and we can receive them also. Like so. As we're sending always the same message, the message is gonna stay the same, but yeah, it's working end to end. So we got it working, and yeah, this is sort of the proper way to set up a codeless infrastructure, the architecture. There's of course much more you need to add to this, many more rules. Maybe deadlift queues, you can look up what that means. It's basically when the SQS fails, so when the receiving message somehow goes wrong, the message is then sent to a backup queue, the deadlift queue, and this can hold the messages for quite a while, and you can basically deal with this then separately. Also, something we didn't do was to delete the message, and of course in the proper service, in a proper server, you would have a while loop that infinitely loops through incoming messages so that you receive them instantaneously. But for this demonstration purposes, we did it on demand. There's also other stuff to add, such as the discovery of schemas when you want to document what events you're sending into your bus. And there's also a tool called Event Catalog. I will maybe go into this in the future. Check out my channel for that if that video is online. But yeah, I hope you found this interesting, and thanks for watching. Have a good day. Bye.